Hello students, now we have studied the quadratic equation and complex number, right? In any examination, in any competitive examination of engineering, complex number as well as the quadratic equation is a very important chapter, right? Every year you'll find at least 2 to 3 questions from these topics, the quadratic equation and complex number. So previously IIT-JEE and the other engineering examination, they have asked many questions, right? In this lecture we are going to solve those questions only and just apply the concept what we have studied in our classes. So now see this carefully and try to apply the same concept in the question, right, to get marks. Thank you. Previous year question of complex and quadratic. We'll start with quadratic, then we'll go for complex number, right? So first question, JEE Mains 2015, right? We have taken few of the questions of quadratic and a few questions of complex. A minus 1 x square and x to the power 4 is given. In this equation also you can see x square plus x, this is plus 1, right? The whole square is given and we have to write the roots are real and distinct, then we have to find values of a. So what is the key point of this question, right? So first is the key point. So this x to the power 4 plus x square plus 1, this will be factorized into two parts. This will be x square plus x plus 1 into x square minus x plus 1. You have to remember this. The factorization of x to the power 4 plus x square plus 1 into two parts as this and this, right? So this is again x square plus x plus 1, right? So we can take out x square plus x plus 1 as common. So what I'm getting, a minus 1 x square minus x plus 1 plus a plus 1 x square plus x plus 1 is equal to 0, right? While solving these two, right, coefficient of x square will take to 2a square and minus a and so on, right? So what we are getting after solving this is twice of ax square, 2 common out from this, plus x plus a is equal to 0, right? 2 is not equal to 0. So this must be equal to 0. And we know that for roots are real and distinct, discriminant of this is greater than 0. And discriminant means b square, that's a only, minus 4ac greater than 0. Make the number line. This will be 0 at minus half and plus half, right? Put any value, this will be negative, positive, negative. What we require, the positive part. So minus half to half, right? A belongs to this, right? But see, if I'm putting a is equal to 0 in this case, right? A is equal to 0, this x to the power 4 will be cancelled out, x square will be not there. So 0 is not included in this. So we are getting the answer, right? Minus half to half excluding 0, right? One of the beautiful question, the key point, you have to factorize x to the power 4 plus x square plus 1, right? The next one, again, a beautiful question, right? Almost 3 times IIT Mains or Advanced, they have asked this question, right? In different form. Anything is defined like an is defined as alpha to the power n minus beta to the power n, and a10, a8 and a9, we have to find relation between these, right? So how to find the relation, how to establish the relation? See, alpha and beta are the roots of this equation. So alpha will satisfy this as well as beta will satisfy this, right? First thing. Second, A10 minus 2A8. What is the value of this, right? A10 means alpha to the power 10 minus beta to the power 10 minus twice of alpha to the power 8 minus beta to the power 8, right? This is A10 minus A, the numerator one, right? See, this alpha to the power 8 is common from this. Alpha square minus 2 minus beta to the power 8 is common. Then this will be beta square minus 2. Since alpha is the root of this equation, the given equation, so alpha square minus 2 is equal to 6 alpha. So we can rewrite this as alpha to the power 8 into 6 alpha minus beta to the power 8 into 6 beta, right? 6 will be common out. Alpha to the power 9 minus beta to the power 9. And this, we know that this is nothing but A9 only, right? So, right, A9 only, and this is given 2A9, 2 and cancel out. So you are getting the answer 3 in this case, right? Beautiful question. You have to remember this. You have to apply this to getting relation between A9, A10 and A8. Remember this question. This is very important. You'll get question like this maybe, right? Now, next is the value of k for which the each of the root of the equation is greater than k. Location of the root. Remember this, we have already studied this, right? Greater than 3. So the graph in this case, quadratic will be something like this. Point 3 is here only, right? So what we required? First condition was d greater than equal to 0, right? Second, a, that is 1 here, and f3 must be greater than 0. And third, you know that minus b by 2a. For this case, this is 6k. Minus b by 2a must be greater than 3, right? So these three conditions we have to apply, and then just we have to go for that, right? So d greater than equal to 0, f3 greater than 0. If I'm writing f3 greater than 0, this will be 9 minus 18k plus 2 minus 2k plus 9k square greater than 0. Now factorize this. Directly this is coming as k minus 1 into 9k minus 11 must be greater than 0. This is the first one. For discriminant d greater than equal to 0, this is 36k square minus 8 plus 8k minus 36k square. Again, this is coming greater than equal to 0. 36k square will be cancelled out, and you are getting k minus 1, 8 common out, greater than equal to 0, right? From this we can say k is greater than equal to 1, right? From this we are getting k greater than equal to 1, and from this we are getting k and 11 by 9 to 11 9 greater than values, right? So first is this, second in this, and third minus b by 2a, right? So this is 3k greater than 1. So first one, this is second one, and this is third one. So we have to apply all three, and then we have to see which one is like going for our correct option and correct answer, right? So see, first greater than 0, so 1 and 11 by 9. These are the points. Less than 1, greater than 11 by 9. From second, I'm getting greater than equal to 1. So these are the points. And k greater than 1 by 3. 1 by 3, right? Applying all, this will be 11 by 9 to infinity. Okay, so, right, getting second option for this, right? Now, the third one, if the roots of the equation is equal in magnitude but opposite in sign, then product of the root is, right? The roots of the equation are equal in magnitude and opposite in sign means we have to see the coefficient of x square. This is 1 upon x plus p plus 1 upon x plus q is equal to 1, right? So after solving this, the cross multiplication, we are getting x square plus p plus q minus 2r into x minus r times p plus q plus pq is equal to 0, right? So if this condition is coming for 0, right, q is going there, right? And we know that the equal in magnitude but opposite in sign, so coefficient of x, only I require this thing, right? Coefficient of x opposite in sign, right? So opposite in sign means same in magnitude, then this will be p plus q minus 2r is equal to 0. So r is equal to p plus q by 2, right? Okay. And what we have to find? We have to find product of the root, right? We have relation, and the product of the root alpha into beta is nothing but minus r into p plus q plus pq, put the value of r, minus of p plus q by 2 plus p plus q plus pq. You are getting minus of p square plus q square by 2. This is again a simple question, but right, essentially you have to use the basic formulas. 100% you are getting the answer on this, right? Alpha and beta are the roots of the equation. X square minus 4 root 2 kx, and log of this is given for some k, right? And alpha square plus beta square is 66. Then find alpha cube plus beta cube, right? See, first thing, we have to find the sum of the roots in this case. So alpha plus beta is 4 root 2 k. Alpha into beta, product will be, we know that this k will be go into the power, and this is nothing but only 2 into k to the power 4 minus 1. This is the property of logarithm we are applying there, right? And alpha square plus beta square with the help of alpha plus beta, and this I can find alpha plus beta the whole square minus 2 alpha beta, right? So what we are getting in this case is 4 root 2k the whole square minus twice of 2k to the power 4 minus 1, right? So this, and this is given as, right, in the question this is given as 66, right? 16 into 2 and 2 to 4. Then after complete like cancelling out this 4, we are getting k to the power 4 minus 8k square plus 16 is equal to 0, right? This is the giving you the complete square form. K square minus 4 the whole square is equal to 0, and we are getting value of k is plus or minus 2. Now we have to apply this k for alpha cube plus beta cube. And again, for alpha cube plus beta cube, you know the formula, alpha plus beta, the whole cube minus 3 alpha beta into alpha plus beta, right? So alpha plus beta is now 8 root 2 the whole cube. Only the calculation one, right? Simple question, but concentrate on calculation, right? 8 3 and just you can take out the common. So this will be 280 root 2, right? So these, I guess these are the simple question. Only you have to take care of the calculation. Now, sum of the roots of the equation x square plus mod of 2x minus 3 minus 4 is, right? So look into this case, the modulus is given, right? So we don't have any idea how this modulus will work, right? So case first, I'm saying like if 2x minus 3 is greater than 0, then this will be open as positive, and the restriction is there is x greater than 3 by 2. X square plus 2x minus 3 minus 4 is equal to 0, right? So x is equal to minus p plus minus the basic formula I'm applying, 2 root 2, right? Minus will not satisfy because x we have to take as greater than 3 by 2. Case 2, 2x minus 3 less than 0, right? In this case, this is x square minus 2x plus 3 minus 4 is equal to 0, right? This is 3, right? Greater than 0. So this will be x square minus 2x minus 1 is equal to 0. From this, I'll get the value of x, right? So x in this case is 1 minus root 2, right? So x less than 3 by 2. So only this value will satisfy, second will not satisfy, right? So one value we got as minus 1 plus 2 root 2, and second is 1 minus root 2. So sum of the root in this case, right, sum of both the values will be, right, 1 cancel out, and this will be only root of 2, right? So simple question, right? But you have to careful. Parental condition is given, like in this case, if you're taking 2x minus 3 less than 0 means x is less than 3 by 2. Only you have to take the value where this will be less than 3 by 2, right? So a few of the questions of quadratic we have done this. Now we'll go for the complex one. Complex number, right? So complex number is one of the important chapter, and very good questions will come for complex number. Like a complex number z is said to be unimodulus if mod z is given as 1. This is the definition, we know that. Suppose z1 and z2 are complex number and this is unimodulus. So mod of this will be 1, right? And z2 is not unimodulus, okay? Means mod of z2 is given not equal to 1, then Z1 lies on. So straight line, parabola, circle, and okay, let's see how to go for this, right? So the key point is modulus of this is 1, right? So we'll start from there only, right? So modulus of Z1 minus 2Z2 upon 2 minus Z1 Z2 mod is equal to 1. So Z1 minus 2Z2 mod is equals to 2 minus Z1 Z2, right? Squaring both sides, right? We know the formula if it is given mod Z square. So this is Z bar. Applying this, so open this, we'll getting mod Z1 square plus 4 mod Z2 square minus 4 times real part of Z1 Z2 bar. Similarly, 4 plus Z1 Z2 mod square minus 4 times of real of Z1 Z2 bar. We can cancel out this, right? And now this is ready. for factorization, right? With factorization, we can see that, right? Or we can write mod z1 square minus 4 plus, in this case, right, 4 mod z1 square minus mod z1 square plus mod z2 square. This is z2, right? For z2, right? Mod z1 square into z2 square is equal to 0. This I'm writing. Mod z1 is splitting this, right? Right. So this given to this, so one there, and 4 mod z2 square minus this thing, right? So z2 square I'm taking common out from this. So I'm getting z1 square minus 4 as common as, right? And 1 minus mod of z2 square is equal to 0. Since it is given that this is not equal to 0, right? So only mod z1 square is equal to 4, right? Mod z1 square is equal to 4 means this is given circle with radius as 2, right? Radius as 2, right? So from unimodulus, every time you have to go for this and easily will get the answer, right? This you can use for equality sign and inequalities also, right? In both the case, the process, the working will be this only. For the complex number z of the form 1 plus I alpha, z square is x plus iy, right? It is given, then we have to find which one will be the correct option for this, right? Correct option for this means we have to like see how this complex number will satisfy the equation in x and y, right? So z is equal to 1 plus I alpha, right? Z square. So z square is nothing but 1 plus I alpha. The whole square is equal to x plus I y. Compare both the terms with 1 minus alpha square is equal to x, and y is getting 2 alpha, right? So we have to eliminate alpha. So we can rewrite this as 1 minus y square by 4 is equals to x, or y square plus 4x minus 4 is equal to 0 will be the complex number what we require, right? Now, if Z1, Z2, Z3, Z4 are two pair of complex conjugate number, then Z1 by Z4 argument plus argument of Z3 by Z4. First, you have to see what information is given. So information given is Z1 bar is nothing but Z2 and Z3 bar is nothing but Z4, right? These two informations are very, very, very important. And what we have to find, argument of this plus. What is the formula for that? So arg of Z1 by Z4 plus arg of Z3 by Z4, right? So we can rewrite as Z1 minus arg of Z4 plus arg of Z2 minus arg of Z3, right? And by formula, we know that these two are conjugate of each other, Z1 and Z2, right? So we can apply the formula as argument of Z1 minus arg of Z4 as Z3 bar plus arg of Z2 is Z1 of bar minus arg of Z3, right? And we have already seen the formula, the basic formula of this. This will be arg of Z1 plus arg of Z3 minus of arg of Z1 minus arg of Z3, right? All cancel out, giving you the answer that is 0, right? See, one of the beautiful question, and many times you'll see this question, right? Z is a complex number, mod Z greater than equal to 1, equal to 1, then minimum value of z plus 1 by z, right? Minimum value of z plus 1 by z, right? And right, this may be the question, right? But in this question, they have asked with the constant, right? Maybe the question will be converted into z plus 1 by z. Many times you have seen that question, but in IT means they have asked the question z plus half, right? This value is given half. Then how to find this? See this, right? Since 2 is given less than equal to half, right? So we can rewrite this z as z plus half minus half is in the mod. By triangle inequalities, we know that this will be z plus 1 by 2 plus 1 by 2, right? So now directly we are just guess this z plus 1 by z is greater than equal to 2 minus 1 by 2, and that's only 3 by 2, right? So minimum value of this is 3 by 2, and right, so like 3 by 2 is the value of this, and maximum what we can go, that's given as 2, right? So beautiful question, but carefully we can do that, right? So lot many question will get of complex number and quadratic in IT examination. So carefully we have to go with the concept, but all the question will be from the basic concept of complex number and quadratic. So revise the basic concepts and go through that. 100% will get the marks on this.